Hello everyone, this is extra note for this electrostatic worksheet number 1. So we're looking at this worksheet for Coulomb's law, and one of the questions in here is not like the other because the charges are actually at an angle to each other. Now, so what happened in here is you have 3-point charge, question number 8. 3-point charges are placed at the corner of a right angle triangle. Calculate the total force, the net electric force on the charge with the X on it, which is that one. Now, we're going to name them again, right? So otherwise, it's very hard to call which one is which. This is charge 1. And then from here, from the top, so we will have charge 2. So this is charge 2. And so I'm just going to put it right here. So this is charge 2. And this is charge 3. Okay, now look at the charge itself. All 3 coulomb, 3 microcoulomb, 4 microcoulomb, and 4 microcoulomb, and they're all positive. Okay, now the only force that we care about is the force on charge X, which is charge 2. So I don't care about all the forces on anything else. I care about that one. So we're going to look at two objects at a time, just like the one before. Let's look at 1 and 2. Now between 1 and 2, they're both positive. So what happened to the force between them? Well, it should be repelling, right? So there should be a force like that and like that, repelling. So 1 and 2 should be repelling each other, but I only care about 2, so I'm going to erase the one on 1. I'm only going to care about the one on 2. Let's name that one though. So this is going to be called the force between 1 and 2, F12, and it's going to the right hand side, right? Now, and then we have another one. So this one's going to the right hand side, as we can see. So right hand side. There we go. Now, and then we're going to ignore charge 1. We're now going to look at 2 and 3. If you look at 2 and 3, we are going to have something different. So we are actually going to have a force that's pointing either upward or downward. Why would that be? Because they're both positive charge and they repel. But do I care about charge 3? I do not. Right, so I don't care about charge 3. Charge 3 be gone. I only care about the force on charge 2. And what should we name that one? We should name that one force 2, 3, because it's the charge between 2 and 3. And this one goes upward direction. Yeah, this one goes up. Now, because the two forces are not pointing in the same direction, or opposite even, you cannot actually just add the numbers or subtract the numbers together. You have to draw a vector diagram and find angle and then do that. Okay, so let's go. Now, the procedure at this point is actually the same as the last example that we did, which is just get F12 and F23 separately. So force, so we have two forces, right? So let's say the purple one, which is a force 1, 2, and that is equal to, now I'm going to stop writing K. As I said earlier, I'm going to stop writing K soon. So now it's that time. So K, which is 9 times 10 to the 9. You should just know that. So two forces, right? Charge 1, 3 times 10 to the negative 6. Right here. How about charge 2? Q1, Q2, right? 4 times 10 to the negative 6, okay? So 4 times 10 to the negative 6. So that's charge 1 and charge 2. Over distance, 0.6. Okay, so 0.6, 0.6, and square. Okay, don't forget the square. Now, that is going to be approximately 0.3 Newton. Let me use the color code again. Okay, so 0.3 Newton. And that's going to the, which direction? That's going to the, I guess I could say east and north. Okay, you know what? Just say east then. So at least we can have an answer that has like north, east, southwest, right? At the end. So that. And then we have another force, which is the orange one that's pointing to the north, which is F23. So force between 2 and 3. So that means we are going to lead the charge between 2 and 3 also. So the charge between 2 and 3. So there, charge 2 is 4 times 10 to the negative 6. So charge 2 is 4 times 10 to the negative 6. And then we have to have charge 3. Charge 3 is 4 times 10 to the negative 6 also. So charge 2 and 3 is actually the same amount. The distance between them is also 0.6. Okay, so that's just convenient. I guess. Doesn't have to be exactly in the middle though. Okay, so equal total at the end. So that is going to be 0.4 Newton. Now this one goes north. Okay. They're both positive number. We don't use any negative in our equation in electrostatic. And one go east, one go north. So you cannot just add them or subtract them. So what we have to do is draw it as a vector. There are two forces. One go east, one go north. So go east, 0.3. 0.3 Newton go east. Go north, which is the orange force, 0.4. Going north, 0.4 Newton. Okay, go east, then go north. And then resultant. If you go east and go north, the resultant is this way. This is your net force. Net electric force pointing in that direction. Now, you can find this by using Pythagorean theorem. So we need two things from here, right? So we need the magnitude and we also need the angle. Okay, so now you should be able to actually do this. So I'm going to stop here. So the net force should be 0.5. I mean, you can even see the 0.3, 0.4. If you do Pythagorean theorem, 0.3 square plus 0.4 square is 0.5 square. So, and then you can have an angle. So you at the end, you should have the net force on charge 2, which is the one with the X on it. And then you should have like a number. So the force on it. And that should be 0.5 Newton. And then you should get an angle. Okay, so you can do that as practice, but I'm going to stop right here. Okay, goodbye everyone, and stay safe.